Scott, what are we talking about when we're talking about knowledge graph or knowledge base? What is that in search engine terms?
Knowledge graph is really just simply like any other graph where, the nodes are the entities themselves, and then the edges in that graph are describing the relationship between those individual connections or those nodes in that graph. And you can have many different edges between these nodes, right? So you can have many different relationships that Paris might have to France, right?
You're founded and all that kind of stuff, right?
Yeah. So when we're talking about a knowledge graph, we're simply just talking about the graph of this knowledge base that's already out there. The biggest one being Wikipedia.
So knowledge graph optimization can result in better keyword rankings for things that are on your website if done correctly. Is that a correct statement?
Yeah, you're enabling the search engines to understand those entities that are in the content, and more importantly, you can actually help disambiguate those entities for search engines. That's one of the harder things to do. Which gives
us goal number 2: is if we're a growing authority, name, author, whatever, and we like to make the search appearance that people see when they search for our name look a little bit more favorable. This understanding of how the knowledge graph works and how the knowledge base works could be the first place to start if you're looking to make sure when somebody does search for your name that you sort of control or influence what appears, right?
Yeah. Obviously Ford can mean many things, right? It can mean the company, it can mean the actual car, it could mean a previous president, U.S. president. So there's no official documentation on how the Google Knowledge Graph is implemented. We'll talk about some cool implementations here in a second, one of which Brew used. But according to Google, the information is retrieved from many sources, including they talk about it comes from the CIA World Factbook, Wikidata, which is the structured version of Wikipedia, and then just simply straight from Wikipedia. They may have just harvested Wikipedia.
Wait, there's more structured data than what you see in Wikipedia? That's interesting.
Yeah.
I didn't know that.
So Wikidata is essentially the structured version of Wikipedia. Using these knowledge graphs, you can start querying these relationships and start to understand and infer the new relationships that weren't there before, just simply by RDF and Sparkle are all languages that allow you to query a lot of these knowledge graphs and get information out that you're looking for. And so this is really important from a search engine's perspective in a number of ways. So knowledge graphs may make use of many different ontologies. We call them ontologies, and they're essentially different relationships, right? We think of them as sort of like standardized relationships. By building these knowledge graphs, we're allowing a logical inference, right, for retrieving I guess we call it implicit knowledge, right? Rather than only allowing queries that requested explicit knowledge, right? So in the past, you'd type in something into Google and it would be just literal, right? It would just give you exactly what you're looking for.
Exact match of the keyword you typed.
Right. Yeah. And now what they're doing is really the ability to take what you're writing, what you're typing in as a query and infer what you really mean as a user of that search engine, and
things,
that
not
inference,
strings.
Yeah, things, not strings. And the inference really that comes from this knowledge graph technology. So DBpedia is another example. DBpedia, DBPEDIA. That's a knowledge graph out there, and in fact, that's the one that Brew used.
Okay.
Why do we use DBpedia over Wikidata? Primarily, they both pull their data from Wikipedia, right? They're basically scraping Wikipedia, and they're trying to create the relational structure among all of those entries. Yeah. DBpedia is kind of cool because they allow RDF and Sparkle. RDF stands for Resource Description Framework, right? Mm-hmm. So the RDF is sort of a standard model for data exchange on the web, and RDF has features that facilitate data merging even if the underlying schemas differ. So in other words, if you're getting sources from different pieces of data, and typically when you're dealing with big data, it's never clean data. It's different schemas, and you're trying to basically pull from different sources. Not everybody has the same relationships that they define. A good example is location, right? So not every entity has a location associated with it, but because we use this resource description framework, we're able to merge all of these sources together, some that have location data and some that don't. And I can still make a query against all of that data and say, hey, if there's the location data, please bring that back to me, and I want to do something with that, right? So as an SEO tool maker, right, at Market Brew, we're just trying to apply this to the product, right? In Market Brew model, you can go to any web page and you'll see all the content on that page with all the named entities linked. And each link then links into our knowledge graph, where that entity has an abstract, it has a summary, it has relationships, it has a parent relationship, it has a child relationship,